So today, page 194, what we're talking about today are bisectors. Okay? Bisectors. So what we know about a bisector is this. A bisector will cut something, we'll say something, into two equal parts. Okay? So bisector. Now the word theorem in geometry is just a fancy word for rule. They use the word theorem to say here's a geometry rule that we could prove. Okay? So we won't do any proving, but just know that when they use the word theorem, it's a word that says it's a math rule. Okay? When you see the word theorem, it just means math rule. Okay? So perpendicular bisector theorem. Okay? So let's read it. In a plane, that's a flat surface, right? If a point lies on the perpendicular bisector of a segment, then it's equidistant from the endpoints. Let's see what they mean. So here's point C, okay? Let's look at what they mean. Here's this line. Here's line PC, okay? Line CP cuts AB in half at 90, doesn't it, right?
Yes.
So that means first of all, you know these two are equal because it got cut in half. So we know AP is equal to PA. Okay, those two pieces are equal. And that's why they use their little dashes to show equal, okay? We also know that any point like this C right here, it makes this distance equal to here, okay? So this is saying that C is on the line, so I know that AC is equal to BC. So I also know that this line has to be equal to this line. Makes sense, doesn't it? Okay? Makes sense? Okay. Now the word converse means just the opposite.
Wait, out of curiosity, why
Yeah.
did they draw the two dashes on the BC and AC?
Right, because they wanted us to come up with that. Totally right. Yep. They wanted us to come up with that. And now we can do it now, Ben, can't we? We can go boom, 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 boom. How's that? And so when we use our dashes, what I did was I did different dashes because it's these two, right? Does that make sense? I want that one equal to that one. I already have that equal to that. Nice job, Ben. Okay. Now, let's take a look at this. Okay, the word converse means opposite. So if we said this, listen, watch my hands. Watch my hands, okay? If I have a perpendicular bisector, then points are equal distance. Okay, if I have a perpendicular bisector, then points are equal distance. Now watch, I'm going to say just the opposite. It's the converse. If points are equal distance, then I have a bisector. If points are equal distance, I have a bisector. See, I'm just saying just the opposite. So converse is to take your statement, here's your statement if, here's your conclusion, and just say it backwards. That's all a converse is.
So AB would be BA.
Right, so we can say this, because this side is equal to this side, okay, because, so I'm just saying if AD is equal to BD, then we know that this is a perpendicular bisector. Then we can say that CP, line CP, is a perpendicular bisector, okay? So it's just saying the opposite. If these two sides are equal, right, and these two sides are equal, then this must be a perpendicular bisector, okay? It's just saying just the opposite, okay?
Is there any cool sign so you don't have to write perpendicular bisector?
Well, perpendicular, definitely. That's simple for perpendicular, right? Not really bisector, no. Yeah, yep. That means perpendicular. There's no cool sign for bisector, though. Okay, does that make sense? If you cut something in half, you got two equal parts, right? If you have two equal parts, you cut it in half. See, I said just the opposite, didn't I? If you cut something in half, you have two equal parts. If I have two equal parts, then it got cut in half. Just saying the opposite. That's all I'm saying. Okay, now let's move to the angle bisector, okay? Yes, I will. Okay. I have to ignore that, teaching. And they'll call back, or I'll call them back. Okay, ready for the next one?
All right.
Sliding over. Now, we also have an angle bisector. And we did that with our drawing, right? So if this is if AD,
Can you move it down?
yeah, I sure can. Sorry about that. So if AD, thank you, AD, leave me alone, I'm teaching. Doesn't matter. So AD is cutting this angle in half. So AD bisects angle BAC, right? Okay, AD bisects angle BAC, okay? Then what happens is we know that if it bisects, we know this angle here is equal to this angle here, right? Just cut it in half. I know this angle here is equal to this angle here. So I also know then angle, the measure of angle BAD is equal to the measure of angle CAD. So all I'm saying is that this angle is equal to this angle. Got cut in half, right? Got cut in half. So this angle here is equal to this angle here because it got cut in half, right? You with me? Now, if you got a point D that's perpendicular to either one of these, this line's always going to have to be equal to this line, okay? Always. If it goes perpendicular, then I know that this is going to be equal to this, okay? If you've got a point on, if you have a point on the bisector, then the line perpendicular to it, these two sides would always be equal. And it looks like it, doesn't it? Don't those look equal? Okay, and the opposite is true. I will answer you later. It must be important, but we'll get to you later. I'm teaching. So now, the opposite is true. If BD is equal to CD, yes, then AD is a bisector. You'll have to wait. No, somebody wants me like right now, but they'll have to wait until I'm done teaching. Okay, now they'll have to wait. Almost done. Okay, I'll check. I don't know who this is. Looks like 662. Looks like a reaction number. Okay, so real quick, let's turn the page. Okay, turn the page. Okay. So this is pretty easy. Okay, watch. Shh, 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 shh. This is pretty easy. Boys, obviously we're not mature enough to hang on to these. So let me just grab those from you. Okay, here we go. Check it out. Now, it's a perpendicular bisector, isn't it? So if this is 6, this is 6, this is 9, what's AB? It's that easy. What does AB have to be, Brian? Are you watching? What is this? What? 9. You guys agree? It's that easy. It's that easy. It's 9. We have a perpendicular bisector, so it cut things in half. If this is 6, this is 6, this is 9, this is 9. Easy, right? Okay. 2. Yep, if this is 7, this is 7, this is 3, this is 3. Right? Easy. Okay. Now, 3 is a little bit different. 3 is going to take a little bit of algebra, but not bad. I do know, though, that this side is equal to this side, right? So I'm going to take my 2x plus 2 equals 3x. Okay. You with me? I just set them equal. I'm going to go and solve. Minus 2x minus 2x. 2 is equal to 1x or x. So x is 2. Okay, that's great, but that's not the answer. That's not the answer because what we want to find is SU. We're not done. We're not done. We have x, but we need SU. Well, SU is easy because I just plug that into here, right? So I take my 2, plug my 2 right into there. I'll have 2 times 2 plus 2, right? I take my x as 2. Yeah, totally right, Brian. 4 plus 2 is 6. Nice job. Nice job. So when you get these answers and you solve for x, x is not the answer. The question is to find this length. We plug it in, we get it. Nice job. Okay. Okay, number 4. How am I doing? So far, so good? Okay, number 4. Okay. Now we need the perpendicular bisector of this line. So let's find first the slope first. Let's find the slope of AB. Okay. First, let's find the slope of AB. So AB, it looks like it goes up 2 over 1, up 2 over 1. So the slope of AB is 2 over 1, okay? So then the perpendicular slope is the opposite, negative 1 over 2. Okay, the perpendicular slope has to be the opposite. It's called the negative reciprocal, which is negative 1 over 2. So the slope of AB is up 2 over 1, up 2 over 1. So then the opposite slope would be negative 1 over 2, okay? Now I know that I need the midpoint.
Negative 1 over 2.
Yeah, the midpoint is right here. You guys agree with that? That looks like right in the middle. Does that look like the midpoint? Okay, that looks like the midpoint. I'll call that M. So my midpoint's at the point 1, 0. There's my midpoint, okay? So then I should be able to draw my line in. So my line, my perpendicular bisector line, goes through right here. It's going to look something like this, right? It's going to lay like this, so it's at 90. Does that make sense? So let's go from here down 1 over 2. Okay? And so my perpendicular bisector is right there. Okay, now, what's the equation of this line? Well, my equation has to be y equals down 1 over 2 minus 1 over 2x plus, goes right through it 1/2, doesn't it? Okay. How am I doing? I will. So I did two things. I found the slope of AB and made it the opposite. Found the slope of AB and made it the opposite. Then I drew in the line by going from the midpoint. Found the midpoint, went down 1 over 2, drew in my line. Goes through it 1/2, and I have my equation of the line. Down 1 over 2, that's my negative 1 over 2x, and it goes through it 1/2, okay? So I needed to find, for bisector, I needed to find the midpoint, found the middle of it, and I needed to find the opposite slope, so it's perpendicular, all right? Almost done. Almost done. Okay? Okay, some of these are actually pretty easy. I think you guys will agree. Are you ready for 5? Okay, what's this angle right here? 20, everybody agree? It's that easy. Has to be because we know it's a bisector, right? It's an angle bisector. It's an angle bisector. So it has to be 20 degrees. Okay? What's this line CD? What's the length of CD? 5. Everybody agree? It's 5 because we have a angle bisector. Okay, does that make sense? Okay. Now BD, am I going too fast? Okay. BD, I know that this side is equal to this side because I've got an angle bisector, okay? So what I have to do then is set this one equal to this one and solve. Well, I can do that. I go, okay, what's 3x plus 1 set equal to 5x minus 1, right? And I got to solve. I'm going to go minus 3x of 1 equals 2x minus 1, right? Plus 1, 2 equals 2x, right? Divide by 2, and I get x equals 1. Okay, but that's not the answer. X equals 1 is not the answer because what I want to find is BD, right? I'm going to find BD, which is right here. So plug it in.
Plug it into 3.
Yeah, plug it in right there. So I'll have a 3 times a 1 plus 1, which is 4. There we go. All right, Let me stop recording, and
That's also at angle bisector.
yeah.